Hi, welcome back guys. On this video we're going to look at representing organic compounds. In simpler terms, how do we express organic compounds, or how do we write them? So we use a variety of ways to draw and write organic compounds. We either make use of molecular formula, condensed structural formula, or also use a full structural formula. Now, before we can also do that, there are terms that I want us to look at before maybe we can discuss those three types of formulas that we use to represent organic compounds. So we're going to start maybe by looking at the homologous series. Now, how do we define it? Now, we define it as a series of organic compounds that can be described by the same general formula. So a homologous series, guys, it represents a group of organic compounds that have the same general formula. For an example here, I've made an example of alkanes. So you remember in the previous video, we said alkanes, there's a group of compounds that are here. So we use methane, ethane, propane, butane, and all the rest of organic compounds. So all those those names, they form a series of organic compounds. But the group name of it is called what? It is called an alkane. And then the group name, we call it, we don't say group name, but we use what the word homologous series. So now we also have an IUPAC name. So a systematic way of naming chemical compounds. So we have a method that we use to name these organic compounds. So which later on I will explain how do we use the system of naming organic compounds, which is the IUPAC system. So now we're also going to look at general formula. So the general formula, what is the general formula? This describes the homologous series formula for similar compounds. So now for similar compound which belong to the same homologous series, so they have a general formula which describes them or which produces those compounds. So that formula, it is called a general formula. Like, let's make an example. We can use the general formula to determine also the molecular formula, which is this one that we're going to define on the next part. So now, how do we use the general formula to determine the molecular formula? So let's take, for example, we have propane here as an example. Propane, we know that is a compound that has 3 carbons. Now, to find the molecular formula of this, we can use this general formula here. Now, where there's C stands for carbon atoms, H stands for hydrogen atoms. So now N stands for number of carbons in this compound. So now propane has 3 carbons. So now we can substitute 3 where there is N. So now how do we go about that? We're going to say C, and then where there's N, put 3, then we say H, and then we can say 2, then there's an N after 2, then therefore we put 3, then we say plus 2. So now when we simplify this, it's going to be C3H, and now 2 times 3, because of the bracket, is going to be 6 plus 2, therefore give us 8. So therefore, we use the general formula now to determine the molecular formula. So what is the molecular formula then? A chemical formula that indicates what? The type of atoms and the correct number of each in the molecule. So now in this molecule that we're discussing here, which is propane, that molecule, it has 2 types of atoms. It has a carbon and a hydrogen. And then the correct number of carbon in that molecule, there are 3. And how many hydrogens there? there are 8. So that's how we write a molecular formula. It shows us the type and the correct number of each atoms that are there, the types of atoms and the correct number of those atoms. So we're also going to discuss now at a structural formula. So this formula shows all the bonds. So which are covalent bonds that we discussed earlier on, that carbon has 4 covalent bonds. So in a structural formula, we show all the bonds and atoms in the molecule. So we show all the bonds and the atoms in the molecule. So now for an example, propane, it has 3 carbons, as we can see here. Let me just highlight all of them here. So there's 3 carbons there. And then there are hydrogens on the other side. So these are hydrogen there. So there are these hydrogens there on this side. There's 3 this side, there's 3 this side, and then there's these ones here. Then give us 8. Then the one that we see there are 8 hydrogens and 3 carbons there. And then now, how do we define now a condensed formula? Now the notation shows the way in which atoms are bonded to each other in a molecule, but does not show all the bonds. So this condensed formula, it shows us the arrangement in how these atoms are arranged in a molecules, their arrangement. But in this molecule also, it does not show all the bonds, just like a structural formula. But here we can show some of the bonds. Like for example, here, if we look at the structural formula of propane, propane has 3, 1, 2, 3. But and then we show all the bonds here on the structural part. When it comes to this one here, we can say CH3, and then that means this carbon has 3 hydrogens. Then the second one is bonded with 2 hydrogen, therefore we say CH2, and then the last one is CH3. So that's how we can indicate the arrangement of the atoms in this molecule. So, or sometimes, as we said, we can show some of the bonds. So maybe it can also be written in this way: CH3, and then it show then CH2, and then it can also be shown in this manner. Yes, this can also represent the condensed structural formula, but we are not showing all the bonds here, as we can see, as we can compare it to this one at the top, which is a structural formula. So we don't show all the bonds. This is also how we can write the condensed structural formula. Now, maybe I can add another example so that maybe you can see what exactly we are talking about. And let me remove this side. Let's just talk about basic alkanes. So let me make an example of a butane. It's an alkane, butane. So now, butane, the word but, we said but, it has how many carbon atoms there in the structure? In this case, this butane has 4 carbon in the structure. So therefore, what would be the molecular formula? And then we can use this, because butane, it belongs in the same group as a propane, therefore it has the same general formula as a propane. So we can use C, where there's N. Remember, it depends number of carbon. Butane has 4, then we can use 4. And then hydrogen, you can say 2. And then where there's N, there we put 4, and then close the bracket and say times plus 2. And then therefore we can say simplify that. If you simplify that, therefore we can say that but H, then 2 times 8, and then plus that, therefore give us 10. So this is the molecular formula. Remember, molecular formula shows the types and the correct number of those atoms or in the molecules. So now we can see here carbon and hydrogen. There's 4 carbon atoms in this molecule, and there's also 10 hydrogen atoms there on that structure or on that molecule. So now, how do we represent this structurally? Therefore, remember, alkanes are saturated hydrocarbons. They have only single bonds between carbon to carbon. So you can represent it in this manner. So now this is how it's going to look like. Then from there, remember, each carbon has 4 covalent bonds around it. There's 4 covalent bonds. So this is how it's going to look like. So then you have 8 hydrogens on the other bonds on the sides. At the end of these bonds, you can add hydrogen like this. So this is how butane is going to look like in a structural formula. Now, when it comes to a condensed structural formula, how do we write it therefore in a condensed structural formula? So now we can represent it in this way. Therefore, we can simply say CH3 and then CH2 and CH2. Then the last one is going to be CH3. So this is how we can represent butane in this condensed formula. Therefore, so now then I'm going to continue now with some more example. And please, guys, if you enjoyed this clip, guys, make sure that you like it and then you share it with others, guys, and make sure that you follow channel, guys, so that we can grow and reach the masses. Thank you very much. See you on the next one.